Determine the maximum area of the surrounding fence given 100 meters of fencing. Oh, we have two walls here and only this much fencing. We have to define some variables first. Let's call this one y, so therefore this distance is also y. Now we could either call this whole thing x, or you could call small segments x. It doesn't really matter as long as you keep your definition, consistent throughout your equations. So in this one, I will keep it like this. So I'll keep this section will be x and this section will be x. Now we need to make three governing equations. So the first governing equation is my perimeter, and the perimeter of here will be, well, I got 2x plus 2y is equal to 100 meters. 100 meters, great. The area of this place is going to be 2x times y. That is going to be the area of the whole thing, okay? Determine the maximum area of the surrounding fence. Yeah, so the whole thing. And then the last equation to make it a max-min problem is going to be dA by d, pick one, x or y. In this case, let's make it y equal to 0. Okay, it doesn't matter. It could be x or y as long as you put your equation that way. So, first things first, I'm going to substitute 1 into 2. And I want to make it in terms of y here because I need to take the derivative of y. So I need to substitute x in to eliminate my x's. Okay, so in the first equation, so I'm going to write it down real quick. I can divide by 2, bring it over there, so I know that x is equal to 50 minus y. Okay, so we'll call that 1a, and then we'll substitute that into 2. So x a is equal to 2 times x, which is 50 minus y. Times y. Okay, let's bring all that in. So a is equal to 100y minus 2y squared. Great. Let's take the derivative of that. So now we have an equation as a function of y. If I made this x, then I would have had to make this in terms of x. Okay, but I made it in terms of y, so we're going to do a as a function of y. So now we're going to take dA by dy, and that's going to be equal to 100 minus 4y. And we're going to set that equal to 0, and that becomes a max-min problem. Okay, that makes it the max-min problem. Min problem. And now we're just going to solve for y. So y is equal to, bring that over, divide it by, it's going to be 25. Therefore, x is going to be equal to, right here, 25 as well. Okay. So, if I made it that this whole distance was x, x would have came out to be 50. Right? Because it just differs that way. So the maximum area that I can have would be 50 times 25.